In this video, I'm going to be talking you through how I made this beautiful dining table consisting of a Cedar of Lebanon top and an ebonised oak underframe. I hope you enjoy watching it and learn a thing or two along the way. So we're going to kick things off with the table legs. These have been designed in a way to allow 8 people to sit around the table while being as unobtrusive as possible. Of course, the easy way to do this is to simply put a leg in each corner, but firstly, this is a bit boring from a project and video perspective, but more importantly, this table is ever so slightly bigger than the table it's due to replace, which has been in situ for over a decade. And so the last thing I wanted was for someone to forget this minor difference and stub their toe as they're walking past it. So this design is what was settled on, and it looks quite simple at first glance, but we've got some big joinery going on here, and the method I'm going to use to construct it is similar to how I constructed the joinery on my Rubo workbench. And so instead of trying to cut these massive bridle joints by hand or on the bandsaw, instead 3 layers of wood are going to be machined up and then sanded down to a precise dimension. You then do the exact same thing with the opposite side of the joint and leave space for it all to intersect together. Now, you don't necessarily need a drum sander in order to do this, but it certainly helps. If you want to do this with a thicknesser, it will work, but it might just take a little bit more tweaking for the perfect fit. And so with all 4 of the legs machined up, the angles on the bottom of the bridle joint could be cut on the miter saw, and then all 3 layers are joined together using dominoes as location. So next, the legs need to be joined together by cutting a small flat spot onto the side of them. Couple of things to note here. First, this angle needs to be exactly the same as the angle at the bottom of the bridle joint at the top of the legs. If it's too obtuse or too acute, the bottom of the bridle joints won't be on the same plane and there'll be gaps in the final joint. Secondly, I need to make sure that when the legs are joined together, the bottom of the bridle joints remain in line with each other for obvious reasons. And so to avoid these inaccuracies, I made a tapering jig for the table saw, but rather than reference at the top or the bottom of the leg, which are currently oversized, this jig references at the bottom of the bridle joint. Oh, it's been a while.
Oh dear. So I'm literally just balancing it.
Yeah, pretty much.
Cool, that's fine then.
To ensure I got a nice, smooth and accurate finish, I used a fresh ripping blade on the table saw, which worked wonders, although it didn't quite have the depth to get all the way through, and so I finished off the cut with my Ryoba saw and then planed the surface perfectly flat and square. These were then glued together, but I didn't bother with any domino locators this time because I didn't want the risk of accidentally exposing one of them while shaping the inside of the legs. And realistically, I could use the opposing component within the bridle joint to keep everything aligned and on the same plane. And so these 2 legs were clamped into one leg by using angled blocks superglued to the outsides. With all of these now assembled, I could begin marking the length of the legs. To get the bottom cut to size, I marked the length from each side using the bottom of the bridle joint as a reference and then squared this across. Now, this probably would have been accurate enough, but I wanted to confirm how perpendicular this line was from the joint in the middle. But instead of just trying to do this with a square, the most accurate way is to do so with geometry. And so, here's a fun lesson for you. If you have a line that you want to draw a perpendicular line from, first, pick a point where you want the lines to intersect. Then get a set of compasses and open them to about half their maximum width and draw 2 marks at a fixed distance from this central point. Then open the compasses up close to their full width and draw 2 lines from each of these new positions, and by joining the points these 2 lines cross, you've now got a perfectly perpendicular line to your original one that crosses your original point. And so it turns out that the first line I drew was ever so slightly off by about a millimetre or so, which I definitely could have got away with, but it was an easy correction to make, and so I rubbed out the old one and replaced it with the geometrically accurate one. And so this process was carried out twice to produce 2 lines, one of which was the overall length of the legs, and the other marked the shoulder line for the tenon. I could then do the same to mark the overall height of the legs, but instead of using the bottom of the bridle joint as a reference, I used the bottom of the legs now that I knew it was perpendicular. These could then be cut on the miter saw, although I did leave a little bit of excess material on the top of the bridle joints that I could plane down later. To create the taper in the middle of the legs, a hole was drilled with a Forstner bit which was a certain distance up from the bottom of the legs. However, on one of them I got my lines mixed up and accidentally marked it from the shoulder line instead, hence why on this one there are 2 holes, but it's fine, they would be removed at a later step. And so the tangents of this circle were joined to the point in which the bridle joint at the top of the legs intersected, but before cutting this on the bandsaw, I decided to rough out the tenon on the bottom of the leg.
Just made it glory hole.
Firstly, the thickness of the tenon was marked out with a mortise gauge on the bottom of the legs, and this same measurement could be transferred to the foot of the table, which I'd previously laminated together. I then set up my miter saw with a trenching cut to rough out the depth and get the bulk of the material weakened before chiseling it out. Originally, I started refining this using the old school method of using a shoulder plane, but I've only got a medium-sized one, and something of this size could probably benefit from using a larger model. So, on the next one. And so once that was roughed out, next I started cutting the tapers for the legs on the bandsaw, cutting as close to the line as possible, before then taking them to the bench to get cleaned up with a spoke shave and then sanded. So now that the inside of the legs were cleaned up, I could get the bridle joint at the top assembled, and inevitably, despite being as accurate as possible, there was always going to be small misalignments between the bridle joints somewhere, resulting in small gaps on the inside of the joint, but this was an easy fix, as I could simply plane the necessary material off the opposite component to close them up. Then once I was happy with the fit, this middle layer could be glued into position before then working on the outer layers. So to make sure I achieved the perfect fit with these outer show faces, I cut out some templates on my miter saw both to test the angle and the lengths required before doing so on the oak itself. I then tapped these into position, ensuring that everything was flush on the inside once fully assembled. So the bottom of these legs comprise of 2 mortise and tenons. Any other time, I would have got away with just doing one massive joint all the way across, but I've got a bottom stretcher coming through this leg, and so having a mortise below it would be utterly pointless. So this double tenon was marked out with a combination square, cut on the bandsaw, and then the shoulder lines were roughed out with a chisel. As for the mortises, the bulk of the waist was drilled out with a pillar drill, then refined to size with the chisel. And you'll see here that I'm using our newly released leadwood mallets to do this, which pack a real punch. Realistically, these are better suited for smaller, more detailed chopping, paring, and assembly operations, but you can see in addition to looking pretty, they're also capable of taking a real beating. The only reason we don't recommend them for mortising is because it's generally better to have something with a longer handle and swing for better power transfer. We're currently working through pre-orders with these mallets, but if you want to get on a notification or waitlist for them, we've got links in the description below if you're interested. When doing big joints like this, I have to account for my clumsiness, and I always have to make sure that I leave chopping back the shoulder lines to the absolute last thing I do. Otherwise, through all the back and forth testing trying to get the right fit, I'd be almost certain to damage them and leave a horrible gap in the final assembly. So once I'd removed the necessary material to get the joints together and I was confident they would bottom out, I sharpened a fresh edge onto my chisel and got them finalised. But before getting these legs permanently assembled, I still had a few things to get sorted. So first I planed the outside faces clean of any glue, and then marked the final height of the legs and got these cut to size on the miter saw. And I could also get the curves on the end of the feet cut and sanded to shape. So, through both of these leg assemblies, we've got a top and bottom stretcher that will be used to fix the tabletop into the legs, as well as stop the underframe from racking. And these are going to be fixed into the legs with through wedged tenons. These tenons are pretty damn long, and seeing as I didn't fancy cutting them by hand, instead I used the table saw with the fresh ripping blade to get me a perfectly parallel cut with a smooth finish. Of course, the circular blade couldn't get all the way to the shoulder lines, and so this needed to be finished up with a shoulder plane and a chisel. Once these tenons have been refined, I knifed around them on the top and bottom of the legs, cut out what I could on the bandsaw, and then refined back to the lines with a chisel. And check this out. Even without a wedge holding them in position, I got the fit tight enough for the stretcher just to support its own weight. So, with all 4 of the joints cut, next I began marking out the locations for the wedges. And I did this by simply tracing the location of the outside of the leg onto the tenon. However, when cutting this hole for the wedge, I moved the line backwards by about 1 millimeter or so, which would give it a bit of extra room for the tenon to be pulled into the wedge if it needed it. And this then got squared round to the other side. Then, the thickness of the wedge was marked out onto one side and transferred round to the other. But instead of using a square to transfer this across, I used a sliding bevel, as the inside of this wall has to be angled exactly the same as the wedge. These holes could then be drilled out on the pillar drill and carefully refined back to the lines on either side with the chisel. Are you ready to see my geen in action?
Yeah. Geen in action.
Geen.
Right, now let me hang off the other end. Can it hold? Well. Oh! How much do you want to risk it?
It would slip out the top. Can I put my bolt in it first?
You can put your bolt in it first.
So that's the stretchers joined to the legs. Next, I'm going to figure out how to join the stretchers to the underside of the top, and for that I'm going to be using my preferred method, which is simply bolting it in place, which makes it easily removable and also allows for wood movement when it's necessary. Before assembling the legs, all of the outside edges were given a small round over, which I figured was a good idea to both protect them and to protect someone injuring themselves by toe punting a sharp corner as they tuck their chairs under the table. This was then followed up with a quick sand 240 grit on all of the faces and edges before being glued together with Titebond. Now I'm sure I'll get a few questions and concerns about wood movement within these legs, and I acknowledge I've got a couple of points of cross-grain construction going on here. If you're not sure what I'm talking about when I say this, your best bet is to just Google it, as I'll spend longer explaining what it is compared to explaining what my solution for it is. My solution for it being, there is no solution. I'm just going to risk it, as I don't think there's quite enough cross-grain construction going on here to create any structural issues, and realistically, the temperature and humidity of this table's final resting place will be pretty constant all year round, and it's in a north-facing room with no direct sunlight hitting it, so I think we'll be okay. Anyway, that was a fun little tangent. Let's start moving on to the fun stuff. Ebonising. Again, I'm not going to sit here and get technical explaining what ebonising is and why it happens, other than to say the solution we're making here is going to react with the natural tannins found within the oak and turn it a bluey black colour. This is done by mixing steel wool and vinegar together and leaving it to sit for about a minimum of 24 hours before straining it and applying it to bare wood. Over the course of an hour, it will begin to darken, and once fully evaporated, in my case, left a beautiful navy blue finish behind. This does slightly raise the grain, which I knocked back with some 320 grit sandpaper before applying a second coat of the solution, just to help sort of even out any patchiness. And by the way, if you're not sure about what ratios of steel wool and vinegar you need to use for this, in the top corner you'll see a link pop up for a test I carried out using 5 different concentrations applied over 5 days, which will give you a good starting point if you want to carry this out yourself. Now I could have just left this there, but I wanted a little more protection and darkness, and so I followed up this ebonising coat with a coat of black Osmo. And you may be asking why I didn't just apply this in the first place, but the reality is that black Osmo doesn't really turn the wood black per se, it just fills the open pores with a black pigment and slightly darkens the rest. But when applied on top of ebonised oak, it really makes a difference visually, and you also get all of the protective benefits of a hard wax oil blend. In fact, later on, I even took this a step further and applied black wax over this, which just looked incredible once finished. Finally, wedges were made to hold the underframe together, and these were ebonised to match the rest of the frame before being tapped in position. Now, while I do have a lot of trust in these joints and these wedges, these legs will be supporting a heavy tabletop that's going to be used a couple of times a day. So I did have concerns about the wedges working loose over the time, which could potentially cause racking. Of course, this could be fixed by simply tapping the wedges back into position, but why bother with having to maintain things like that when it could easily be avoided by shoving a big fat bolt through it to hold it in position? And for the record, all of the fixings I'm using for this table are made of A2 stainless steel, because if you use normal steel in combination with oak, the tannins within the oak itself can actually cause the fixings to corrode and end up causing structural issues. So anyway, with the legs now sorted, I could move on to the tabletop, which is going to be made from a huge slab of Cedar of Lebanon. Now this stuff is actually quite soft, and so if you're planning on using it yourself for a table of any kind, make sure to consider this. But seeing as this table is going to be a present for my folks, firstly, they can get what they're given. Secondly, I'm only a call away from resanding and refinishing it every now and then just to get it back close to its original condition. Now, I was really lucky with this slab in that it did not warp one bit while being sat around in my workshop for months waiting to be used, and so flattening it would be a breeze and I could really maximise the thickness without having to worry about trying to remove any distortion across its width. And so to flatten it, I settled for the trusty router sled method. I've done this once before when making my river table, and it was quite possibly one of the worst experiences in my life. Firstly, I was flattening oak, which is incredibly hard and dense. Secondly, the cutter I was using was way too small. Thirdly, the oak decided to start warping as it was being flattened. And fourth, I was hungover while doing it, so I was hoping it would be an easier experience this time. To start with, we had to get the power tool workbench leveled, and we did this by casting a laser line across the top of it and shimmed up each of the legs until each corner was sitting an equal distance under the laser line, and we just simply measured this with a ruler. Next, a couple of tracks were clamped to either side of the bench, and again these were leveled using the laser line cast over the top of them to make sure they were both in line with one another and were an equal distance from the top of the bench. Next, the tabletop was hot glued to the top of the workbench, and the process of flattening began. So I couldn't be asked to make myself a new sled when doing this, and so I just ended up using the same one I used for the river table, which is why this time I wasn't quite able to get all the way to the edges of the slab. But to finish these off, I made another router jig which would reference off the now flattened part of the table and finish off the rest of it, before then being blended in and flattened with the jointer plane. This could then be followed up with a bit of sanding, and with that, it was sorted. So despite the slab being very sensible and not warping at all during the time it was in my workshop, I still wanted provisions to make sure it stayed that way. But the problem my design has is that the top is only fixed in the middle of the legs, and there's nothing branching across its width to keep the top flat. To solve this, I routed some channels in the underside of the top which would be hidden by the legs once they were bolted in place, and steel box sections would be fixed into them to help prevent movement. And there's a few technicalities to explain here. So firstly, the only place this slab is likely to cup is right in the middle where the growth rings are still curved. In these outer sections where they're closer to being perpendicular to the faces, it's probably not going to be that much of an issue. So realistically, we only need support in the middle. Secondly, while these box sections will be here to prevent cupping across the width, they will not be able to stop the top from shrinking and expanding across its width. So to allow for this movement, elongated slots were milled into the box sections to allow the fixing bolts to slide along them as the table moves. Finally, these box sections are made of steel, and as you've already seen with the ebonising solution, steel likes to react with oak, and in fact when steel has prolonged contact with oak, it can begin corroding. So when fixing these box sections into position, I made sure to make them deep enough so there was no direct contact with the oak legs below. And while the tabletop was still upside down, I could also start debarking the edges using the various tools at my disposal, as well as blend in any branches that were sticking out the sides, and heavily rounded over any sharp corners using my spoke shaves. To clean up the ends of the table, I'm using these new UJK router cutters which have been manufactured in the UK by Axminster Tools and Machinery, and they have a bunch of interesting features that set them apart from your average straight router cutters. Firstly, they have an enhanced shank length for extended reach and a microcarbide ground tip for superior plunging performance. They're made from E&8 steel, which ensures durability and resilience for a stronger, tougher cutter, and they have a Xylon coating which minimises friction, prevents resinous buildup, and enhances wear resistance. They've also done away with all of those annoying K-lines that often get faded with use, and instead use a stop insertion ring that both makes setup much easier, and as an added benefit, seals the collet from dust buildup. You'll also find all of the important information such as cutting speeds and dimensions printed directly onto the router cutter's shank, and they come in this simple but effective recyclable packaging which is easy to dispose of responsibly. If you're interested in trying out these cutters, you'll find a link in the description below. Now that everything was sanded, I could start finishing the top, and for that I chose to use Natura 1 Coat after being very impressed by the results of Mark Spagnolo's hard wax oil comparison he recently released. Unlike the hard wax oils I often use, this is a two-part finish that needs to be mixed in a 3:1 ratio before application to ensure it cures correctly. So to finish the underside of the top, I used a foam brush to apply it, and it worked amazing. In fact, I managed to cover the entire surface and all of the edges with only 100 milliliters of finish, and remember, you only technically need one coat of this stuff. However, in my excitement to use a new finish, I completely forgot to buff off all of the excess, which resulted in a little bit of stickiness that I had to cut back with an abrasive mesh later. Now, I wasn't too worried about this as it was the underside of the top, but if you're going to apply this yourself, make sure to buff off the excess. And then when it came to working on the top of the table, I tried to apply the finish using a squeegee, which is the method recommended by Natura. So as you can see here, I poured it over the surface in a zigzag pattern to help get even coverage and started spreading it around with the squeegee. But after the surface had dried, I noticed that the zigzag pattern had been left over. Now, I take full responsibility for this mistake, as I should have known better than to pour it across the grain on such a soft wood. Of course, it would have soaked in unevenly. So if you're doing this yourself, even on a hard and dense wood, I'd recommend pouring it along the grain before spreading it, just to avoid this potentially happening to you. In the end, I just ended up sanding back the middle section where the pattern was most prominent, and I went through a fair few discs in order to do this, which just goes to show how protective and durable this finish is. This was then covered in another layer of Natura 1 coat, which on the upside allowed me to cover the areas of high wear around the edges of the table in another layer of finish. And that's pretty much it complete. After a bit of dressing up, this is what it looked like. My parents absolutely loved it, and if you want to build this yourself, we've got plans in both metric and imperial available in the description below. I hope you enjoyed this video. Thank you very much for watching.